Hi everyone, my name is Miguel Vega and tonight I'll be presenting on CSRF attacks. CSRF stands for Cross-Site Request Forgery. It's a type of web application or web service attack that has been recognized by OWASP as being one of the top vulnerabilities within those technologies. CSRF attacks are made possible when a legitimate user is authenticated into a web application, and then a request is made on behalf of that user by an attacker. So in short, let's say that you're logged into BB&T for your banking application. If that application used an API or um, a similar method to actually submit data to the application for a request to be made, then that URL with the request could be crafted from an external site to where if you were to visit it while being logged in, the action would be executed. And these actions can range basically from transferring funds to changing your account information. It's really only limited by the API for the application itself. This particular attack has been seen throughout the wild, and it is often exploited. It's an attack that's not as well known as cross-site scripting or SQL injections. However, it's just as prevalent and it's just as easy to implement. So essentially, the flaw that allows this attack to be made is taking advantage of the nature of how the internet works. So one of the main benefits of the internet is that you can link from one site to another, and essentially that's what creates websites and web pages, and then you can have content linking back and forth across domains if you would like to. So the problem is that web forms or APIs, web applications, um, the method of inputting data into those applications is not necessarily limited to the application itself. API, the very nature of APIs is to be able to consume them or take advantage of them from outside of the application. My example here, just talks about Google Maps API in that it basically makes their information and their data available to other developers so that they can, build applications on top of it. In this case, Uber or Waze, they don't have their own map system in place, so they just use Google because Google's API allows them to do so. So that's a very benign example. A more malicious example, of course, going back to what I mentioned before with the banks, is that if there's an action to be taken on the banking site itself, it can be launched from anywhere really. It's implied that um, being able to execute the command through the web application itself will allow the request to be crafted in a way that can actually be read by the server. However, if a hacker has any inner working knowledge of how the application works, whether it be by them actually having an account within the same bank, or they possibly could have just been snooping around the application and figuring out how it works, then they too can create this link, and so long as it's accessible by the logged in user, it can be executed. Um, of course, the implications or the outcome is that an authenticated user using their legitimate uh, session token for their login to this site can execute a command or an action without actually intending or meaning to do so. So some common attack vectors for this particular attack can range from anything from a spear phishing email to just a URL embedded within some content on a related page, or something like ads that actually allow content to be loaded within the page itself. The reason why CSRF attacks aren't necessarily as prevalent as SQL injections or cross-site scripting, at least in terms of news media and data breaches and hacks, is that the the activity that can be caused by a successful attack is limited by the API. So if you target one specific user and you are able to have them transfer funds from their account into your account, you're essentially just affecting that one user. It's not necessarily a breach in itself. It's just you were able to successfully fool a particular user into uh, landing into this particular attack, which is a very common practice with many different types of attacks. Doesn't necessarily imply that there was a data breach that occurred. Um, but the timing can be tricky, and that's why these attacks are a little bit harder to implement. In that you, for one, need to have a user who is actively logged into a web application or web service, and two, you then have to actually craft the URL and have them either load it or click on it directly, and that can be done by the various attack vectors that are listed here. Um, Out of the three, the one with the highest success rate would be that of ads. You can specifically purchase an ad to uh, load on a page for a specific domain or specific site. They're not as common within banking applications, but things like social media can also be susceptible to them as well. A very common example that can be seen with social media would be um, you see a post and it's very enticing. It's just some outlandish news and you're curious about reading it. So once you actually click on the post to go view it, it actually executes an action on your behalf, which in this case would be something like um, taking that same post and posting it on your wall so that your friends can see it as well and click on it as well. And essentially, you've created a worm where every time a user clicks on that particular post, the action that's taken is it will again post it under your name and it will be available to a wider audience. So I've listed out quite a few examples. The examples that I have here are more technical code-based examples. So if you're not very familiar with HTML or JavaScript, it's completely okay so long as you understand the concept of what's happening. Um, this one deals with the banking application itself that I mentioned. In this case, say you were to open up an additional tab and you were to go to a site or go to a page. Within this page, there could be an image that's loaded, and normally you would include an image URL within the source of an image and it would show you that image. But in this case, instead of an image URL, we actually have a URL that interfaces directly with the application that the user is logged into. In this case, it would be the banking application, and the action that's taken is it transfers an amount of $1,500 from your account to that of the attacker's account number. Now, you wouldn't necessarily be aware that this is happening since the image itself has a width and a height of 0, meaning that it's essentially invisible. However, that resource is loaded onto the page, causing the action to execute. Um, at that point, if there's no other authentication that's taken place on the server side, then the command will be successful and you will have been essentially robbed of $1,500. Example two is purely a code-based example. Some of the common mitigation techniques uh, that can be implemented by developers is making it to where the application itself only accepts post requests. So essentially, if um, you have a specially crafted URL and you access it, um, that assuming that the application runs an API, then that command could theoretically be executed. However, in instances where developers have implemented only accepting requests from post request, it essentially means that you would be logged into the application, you would type out your content or set up your command in the way that you want it, and then when you actually submit the form, that generates a request that's then posted to the web application server. And the idea is that this functionality wouldn't be able to be replicated elsewhere. However, that is not the case. With this very simple code, essentially, if you were to visit a page that had this loaded, there would be a form um, that would post to the very server that you're logged into, and there's an input field which would change the email address associated with your account to that of another user's, and then the form is actually submitted via JavaScript. So once you load the page, the form is loaded, the field is loaded with um, the hacker's email address, and the form itself is submitted to the application using your session token through JavaScript. So in terms of being crafty or being very technical or finding ways around it, these are just very common tactics that hackers are able to implement to circumvent some of the measures that are in place um, on certain applications or certain software. So what can be done? There's really two very foolproof methods that are heavily implemented across the board by different developers and software engineers. The first of which is what's known as a CSRF token. Basically, what this token is just um, it's a unique string that is included in a hidden input field, meaning, if you go to a form, it takes all the fields from that form whenever you hit submit, and it actually submits them to the server. A hidden field is one that is also submitted to the server, however, you have no visual feedback of it existing. So the CSRF token is included with your form submission so that if this form is replicated elsewhere, perhaps on a different site or via URL, and an attacker is trying to trick you into performing an action without that CSRF token present uh, in their form, the command actually won't be able to be processed, and the server will kick back with a denied um, response to the action. So a CSRF token kind of limits the scope of where requests to the application can be sent um, to the application itself. Um, And then the other method of preventing these attacks, it's not necessarily foolproof in that it prevents any type of attack. However, just forcing a user to re-authenticate whenever they're performing a sensitive action, such as changing, um, information details, adding a new credit card, changing passwords, um, it would actually force the user to re-enter their password to just authenticate and make sure that the person that's committing this action is actually the person that's intended to do so. And this can be seen in many sensitive applications, such as those of banking or e-commerce, or just email. And essentially what it does is it just re-verifies that you are who you say you are for particular actions. Now the downside to this method is that it is only for particular actions. If you were to go to Facebook and want to browse around, maybe make a post, and every single thing you did, from sending a message to posting something on your wall, if it forced you to re-authenticate, then the user experience would be severely degraded. So in terms of implementation, I would say um, forcing reauthentication for sensitive requests would be a good implementation of that solution. However, CSRF tokens should always be added in order to just limit these requests to only that specific application. And in doing so, there's a very good chance that you can mitigate most or all CSRF attacks. However, there have been instances of attackers being able to circumvent these methods, and then it just becomes a way of altering their implementation to, again, block out any hackers. But that concludes my presentation on CSRF attacks. I hope that you learned what these attacks were, what they can actually cause, and how to prevent them. For any additional information, please visit OWASP. Uh, they have a very detailed list of many common web application attacks and scenarios of implementation, how common they are, who's vulnerable, and of course how to remedy them. Thank you all again. Bye.